Okay, so now can you hear me? Hello, can you hear me? Hello.
Yes, we can hear you. We can
Okay,
hear you.
okay. So now let's go. Yeah.
Welcome back.
Okay, so now can you see my screen? Okay, let's go. Okay, so first of all, we try to discuss about that vector area, how you can easily calculate it, the vector area, such as this boundary or polygon, you want to calculate it, this area. So first of all, I also write the comment, suppose vector area, calculate. So for vector area calculate, you can simply take a variable, suppose state area, you can use any variable name. Then you can simply call this boundary polygon shapefile variable name. So in this time, this variable name is that AOI. So just I simply write the AOI, and then use a function geometry and define here as a area. Okay, so basically when you want to calculate the vector area, then we can use here the area function, and we can get the result in area function as a square meter. Okay, then we can easily convert the square kilometer other things. So now I want to print this result, so simply use here the print function, and then simply copy this variable name, and then click to the run. So now we can get the result about this area, how much area is available for this polygon. Okay, it calculating. So now it's calculating the area for this region. Okay, so now we can get the value. You can see this area, we can get how much area is available, and this unit is a square meter. Okay, so now I want to convert the unit, suppose a square kilometer. So for that, I take the another variable. Suppose this variable, I put the variable name, suppose state. I can use any variable name, state area, suppose a square kilometer. Okay, for a square kilometer, we can simply divide it with 1 million. So I simply call the EE dot number, EE dot number. Here you can see, here I use the E dot number because this is a number. This number I want to convert into a square kilometer, and this number is stored in a variable. This variable name is that state area. So simply copy and paste here, and then use here the divide function. So I divide with 1 million. Scientific notation is that 1 into 10 to the power 6, or 1e6. Okay, so now I want to print this value. I get the value in square kilometer unit. Okay, so simply copy and paste here again, and click the run. So now it displays the result about this polygon, how much area is available. We can get the result in square kilometer. So it's working. Okay, so now I can get the result in square kilometer when I want to divide that. And here you can see we can get also some floating number. So if you want, you can use here the round function, round round function. Then all of the floating function will be moved. We can get the only for the integer value. So click to the run. Now I can get only for the integer value for the when I want to add here the round function. So this is the process when you want to work with for the vector area calculation. But when you want to apply the raster image calculation, there are a lot of process we can apply in here, such as for area calculation for the raster, we are using here the single class. Suppose you can see here. For the, we can also, another method is that for the raster calculation, suppose I can write this, suppose area calculation for image. In this time, if you want, you can use here the single class. Suppose you need only calculated the build-up area for year of 2021. How much build-up area is available for this region? You want to calculate only for the single class, only for the build-up area. How much build-up area you can get for this region? How much build-up area you can get in this region? You can easily calculate this area as a build-up area. Okay, so for the calculating single class, we can also apply. So I take the variable, suppose build-up area 2021. Okay, so 2021, I can simply the build-up area 2021. In this time, I need to call this classified image variable name. Okay, this classified image variable name I need to call. So where I can get, you can see this classified variable name is that classified image 2021. I simply copy this variable name because this image, this classified image is stored in this variable. So just I simply copy this variable name and paste here. And then use here the equal. EQ means equal. Now I want to select the build up class value. You can see here for the build up 2021, what's the value I want to use in here? For the build up, I want to use here the 1. Okay, so for that, I can simply use here the 1. Okay, so now I display the result. So put here the map dot add layer and show only for the build up area region. Okay, single class map only for the build up area year of 2021 and paste here. I want to display the color plated, such as I put here the mean, it will be 0, and max, it will be 1. Okay, and use that the plated function. Plated, I put this plated, make a list. I want to put here the gray color where there is the no build up area, and where the build up area I want to show as a red color. Okay, and also put the layer name. This is the build up, suppose 2021. Okay, then click to the run. So in this time, it create only for the single class map. Okay, only for the build up area map year of 2021. So it working. We can get only for the build up area or urban area map for year of 2021 in this time. You can see the layer already added a new layer in here. So we can get this. So we can check about that only for the single class map year of 2021 of urban or build up. Okay, so now you can see in this time, I can only get the build up area or urban area for 2021. Okay, so you can see this map is only represented the build up area, or also you can say that this is an single class map. Okay, for the single class map 2021 of build up area or urban map. Okay, so now you want to calculate this area, how much build up area or how much urban area is available for this map. You want to calculate this type of area. So for that, we can easily write calculate the area for the single class. Suppose I want to take a variable. Suppose this variable is that.
The one we are using now. We are using for our office.
Okay, so I simply take a variable. Suppose area image 2021. You can use any variable name. I put the variable name look like this, and then call this variable name. You can see this map. Okay, this map is stored in this variable build up area 2021. So just I simply copy this variable name and paste here, and then use a function. I just multiply with a function. This function is that ee dot image dot pixel area. So basically this function calculate the area as a square meter. Okay, when I use the function, I can get the pixel area in square meter. So just I simply connect this function with my map. Okay, so because basically this urban map is stored in this variable, so that's why I use this variable name in here and then multiply with my function. Okay, and now I want to calculate the area. So for that, I can simply take a variable, suppose area 2021. Okay, so now you can see here I simply copy this variable name, and I want to use a function. This function, you already know about the function. This function is that reduce region function. Okay, so in this time, for this specific region, I want to calculate it the total pixel area of build up area. Okay, total pixel of build up area. So that's why I simply use the reduce region function and put all of the argument one by one. So first of all, I make a curly bracket start and also use the curly bracket int, and also put all of the things. So first of all, reducer. So reducer is a statistical function. I need to use the total. So ee dot reducer dot sum. I want to calculate the total pixel value of build up area. Then geometry. Geometry is that shapefile variable name. It's this time AOI. Scale is the resolution. In this time 30-meter resolution for Landsat. Okay. And after that, we can simply remove all of the things, not for this time. Okay. So if I face any problem, then I use the max pixel. Otherwise, it's not need. Okay. So then I simply remove all of the things. I simply remove. So now I want to just simply print this area of the build up area. So print. I simply call the area 2021. Okay, so now check the result about this, how much build up area is available for this 2021, and we can get the result in this time a square meter. We can easily convert this a square kilometer or hectare later. Okay, so first we can check our result, what result we can got. So it working, you can see. And when you want to apply the reduced region, you all time get the result as a dictionary. Okay, reduce region all time provide you the result as a dictionary. So in this time it's showing the dictionary computing. So it's working. Okay, so this is our total area. Okay, this is a total area, and now it's calculating how much build up area is available for year of 2021. So it's working, computing this value, and this map is for build up area 2021. We can check the result. Simply click on here, you can see I can get the result, and this unit is that square meter. Okay, square meter. So now I want to convert in square kilometer. So same process we apply in here. So I simply take a variable. Suppose put the variable name such as urban 2021. Okay. Then Okay, I suppose urban 2021 square kilometer. Okay, so this is a number. Okay, so this is a number. This number I want to convert into square kilometer. So use at the art engine dot number. Okay, now this number is stored in a variable. This variable name is the year of 2021. This variable I simply copy and paste here. Okay, and now you can see here this number I want to get from classification. Okay, this classification value this number. Okay, so for that I simply use a function, get function. This number I get from this classification, so simply copy the same name classification and paste here. Okay, and then I simply just divide with 1 million. So divide with 1e6 1 million, and also take the round value I get only for the integer value, so use that the round function. So now simply print this. So print and put at the urban square kilometer, simply copy and then simply print this result. So now I get the result about the urban area for 2021 into a square kilometer unit. So it working, you can see. So it working. Okay, so like I can get the result for this total urban area for 2021. I can get the 52 square kilometer, 52 square kilometer for year of 2021. Okay, so I also cite the notation. Suppose I also make some citations such as this is that urban area 2021. Okay, I give this citation like this. So now this citation I can also add it in this here, so you can easily identify this is the urban area for 2021. So now you can easily apply the same process and also calculated the urban area for 1991. Okay, so let's go how we can easily do that. So for that I can simply copy the same code, from here, simply copy. Okay, simply copy, but in this time I want to apply the same code for year of 1991. Okay, so let's go, we can check how we can do that. So for that, so this analysis for 1991, for that I can simply paste same code. I can simply change the name, suppose change the variable name, suppose 1991, sorry, 1991. Okay, and then I need to check about all this image. Okay, in this time I want to calculate from this image. You can see I want to call LULC 1991. Okay, this classified image I need to call. Okay, I simply go to the app and simply copy this variable name, this classified variable name. You can see classified 1991. Simply copy this variable name and then paste in here, because I want to work with this satellite LULC map now, and this map is stored. This variable name is that classified RF 1991. I simply put here, and then you can check about this build up area, what is the value. So this value is the same 1. Okay, so I simply use that the equal to 1. Okay, I want to show this result for suppose gray and red. So in this time I want to show such as a blue color. Okay, suppose all of the build up area showing as a blue color. For build up area suppose 1991. Okay, for this region. Okay, after that I want to calculate the area, so use that the area image. I put the variable name suppose 1991 and call this variable name, simply copy and paste here, multiply with my function. Okay, after that okay, I simply change the variable name, suppose 1991, and simply call this, simply copy this variable name and paste here and apply reduce region function. All of the things will be same. I want to print this value, so simply copy and paste here And after that, I want to convert it as a square kilometer. So I simply put this name, suppose 9991 square kilometer, and then simply copy this variable name and paste here. I get the result from the classification and divide with 1 million. So now I get the result for the urban area 1991. So 1991. Okay, 1991, and simply copy this variable name and also paste here. So now let's check about this result and also check the map about that urban map year of 1991. Okay, so very quick time we can easily get the result for another time period using the same code. Just simply change the variable name. So now it working, you can see. So we can get the result for urban area 2021 and urban area for 1991. Now we can easily get the change, how much area will be increasing, how much area will be decreasing. This type of result we can easily get in here. So it's working. So it calculating this result about this 2 time period urban area. We can get the urban area for 2021, 51 square kilometer. And now check what about that 1991 about that urban area.
Wow.
Okay, we can get only for the 6. Okay, we can get only for the 6. You can see here.
1991.
And okay, so I need also send in here, suppose.
In 2001.
Okay, so I simply copy and I want to display this result for this. So I need to use this same variable name. So paste here. So now I can get this map for urban map 1991. Okay, and also get that urban map for 2021 and also calculate their area. Okay, so it's working. So I can say I can get only for this urban area in 1991 I can get only for the 6 square kilometer. But in 2021 I find out total 52 square kilometer urban area. And this map is represented the urban area map for year of 1991. And also we already created the map for, you can see this map is represented the urban map for 2021. Okay, we can see lot of area will be increasing in year of 2021. Okay, so first time we can get only for this urban area in here, but in 2021 we can get the lot of area. You can see we can get. Using the same process, you can also apply, such as suppose you want to identify the build-up area, vegetation, or other types of classes. Same process, single class, how you can easily calculate it, and also try to display the result for the single class, only for the build-up area, only for the water body. Okay, so in this time we can work only for the build-up area. So now, if you want to make the change where a urban area mainly change detection map, how you can easily create it for the change detection map between the two time period, year of 1981 and 2021, only for the urban. Okay, where is the urban? You can see for 1981 urban is available in here for this region, but 2021 a lot of area will be increasing the urban area 2021, and we already calculated the value about that. For the urban area 2021 is available 52 square kilometer, and urban area for 1981 we can get only for the 6 square kilometer. You can see a lot of area will be expansion of urban in here. So first time we can get the result only for the 1981 this area, but 2021 lot of new urban area or build up area or settlement will be increasing in this region. Okay, so now if you want to check this result, for that we can easily about the change detection between only for the urban. So let's go about that only for the one class urban. Okay, so what is that about the change detection? So for that, suppose change detection only urban area time period is that 1991 to 2021, this time period only for the urban area change detection. So for that we can simply take a variable, suppose take a variable such as put the variable name, suppose changed. Okay, so before that we can simply need to remap this classification. Okay, for that we can also directly we can use the changed. We need to call the after class and before class. So here you can see 2021 and 1991. So 2021 is the after and 1991 is that before. Okay, so after and before. So 2021 is the after class and 1991 is the before. Okay, so 2021. So I simply call the after class. So after class you can see I simply call this variable name after class 2021. So I simply call this map variable name is that okay, simply copy, okay, after and paste here and use here the subtract with before class. So before is that urban 1991. Okay, so just I simply copy build up area 1991, simply copy and paste here. Okay, after that I want to show the result about the change detection result. So simply use at the map dot add layer and simply copy this variable and also make this color plate such as mean 0 0 and also put here the max 1, and in this time I use here the plated function. So for that plated I want to use here the suppose white and then also put here the suppose red color. Okay, so now I put this layer name, this layer identify the changed. Okay, and now click to the run. Now we can get about the changed result. Where red is available, it means that it will be changed. Okay, where we can get the red pixel value color, it means that it will be changed. Now you can check about this result about the changed map only for the one class. Okay, then about that further lot of all of the class, how you can easily make the change detection map. Okay, so in this time we considered only for the one class, only for the build up. Good working, learning. can see. In this time, here we can get the red color. You can see it will be working, this layer, red and white. Okay, so in this time, here we can get this red color. It means that it will be changed. Okay, and here we can get the white color. It means that for this place there is the no changed. Okay, red color identify there is the changed, and where we can get the white color, it's identify there is the no changed. Okay, suppose suppose in this white color it available for this vegetation, and then in the meantime for 2021 we can also get the vegetation, so there is the no changed. Okay, but here we can get the red color identifies, suppose in 1991 there is the no build up area, but 2021 we can get the build up area. Okay, so in this time it make the map for the change detection map. Red color identify there is the change, and white color identify there is the no changed. Okay, so this type process, thus we can simply call this and have this. So now if you want, you can also calculate it, the transition area. Transition area means that how much area will be converted into the build-up area, how much area convert into this vegetation. So this type of calculation we can also apply. So in this time I try to show you that for all of the class. So all of the class means that water, build-up, vegetation and others. So all of the class I want to show you that how you can easily calculate it, the transition area. Suppose water, how much area water will be increasing in year of 2021, how much build-up area will be increasing year of 2021, how much vegetation will be increasing or decreasing in 2021. So this type of analysis we can easily do in Google Earth Engine platform, and it also called the transition area or transition zone. So for that I also try to discuss about all of the class, not for the single class. Okay, so in this time which process I want to show you that it's called the single class. So single class, how you can easily calculate it, the single class area, as well as also make the single class change detection map. Single class change detection map. So now I talk about that overall this map. We can get the 2 time period map. So LULC 2021. Here we can get all of the classes such as water body, vegetation, build up and other class, and also get the LULC 1991. Here we can also get all of the class. So now between this 2 time period map, how we can easily make the change detection map for all of the class, not only for the single class, all of the class, and also calculated the transition area between this 2 time period. Okay, so let's go about this analysis. So for that, so I simply write the comments such as change detection for all classes between the 2 time period year of 1991 to 2021. Okay, this time period we try to discuss about that change detection for all of the classes such as water body, vegetation and build up area, how we can easily do that. So for that, first of all, I need to remap this classification. So remap this classification I need to use or reclassify. So first of all, I need to make the reclassify. Reclassify from, you can see it will be 0, then 1, then 2, then 3. Okay, from 0 to 3 to 1 to 4. I need to make the reclassify from 0 to 3, this class, to 1 to 4. Okay, I need to reclassify for all of the class. So this is the 0, then 1, then 2, then 3. In this time, it will be 1, water is the 1, then 2, then 3 and 4. So I need to reclassify. First step, when you want to make the change detection, first step is that you need to make the reclassify. Okay, so in this time I reclassify from this tense. So first of all, I take a variable. Suppose this variable name is that before class or classes, and then I simply call the before class. Before class means that past year. Past year in this time, this past year is 1991. Okay, this is the before class. So I simply call this 1991. So I can get this variable in here. You can see I simply call this map. Okay, I simply copy this variable name and paste here and use a function, this function called that remap function. Mainly this remap function make the reclassify. I want to reclassify this class number 0, then 1, then 2, then 3 and make the and generate the new value from 1, 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. So just I simply reclassify. Then I also take the another variable, suppose after classes. Okay, in this time I simply call the after class is that year of 2021, and 2021 this image is stored in a variable. So just I simply call this variable name. So what is the variable name? You can check. Yeah, so this is the variable name. I simply copy for 2021 and then paste here and also reclassify. So use at the remap function and put here this previous class 0, then 1, 1, then 2, then put here the 2, then 3. Okay, and also make this reclassify. 0 will be 1, 1 will be 2, 2, then 2 will be 3, 3 will be 4. So now it will be reclassify. Okay, this class will be reclassify. Okay, so now I want to create the all changed area. So create the all changed area. All changed area. So I simply take a variable, suppose changed, and simply call this after classes. This after class subtract with the before classes. Simply copy the before classes.
Okay, so give me the
Before classes, I simply put that result and use here this NUQ in equal to 0. Okay, and now I want to display result. So use here the map dot add layer and call the changed. Simply paste here. Okay, and display the result such as mean. It will be start from 0 and max 1 and use here the plated function. In this time I want to add here the suppose white color. Where we can get the white color, it means that there is the no change. There is the no change. And where I can get this red color, it means that there is a change. So I simply use the change as a new layer. Change all classes. So now click to the run. So now we can check about the result, about the overall change, all changes, all of the class changes. Okay, now we can get the result.
Please can you mute the other sounds?
Okay, so kindly mute the other sound. So it also, yeah, so kindly mute it. Yeah, okay. Yes, only muted. Okay. Okay, so now it will be working and we can get the overall changes, overall all changes area. So where I can get the white color, it means that there is no change. Suppose in year of 1991, I can get the vegetation, and the present time I also get the vegetation. So there is no change. Then this pixel value showing as a white color, and red color, it where it will be changed. Then we can showing as a red color, and we can get the all of the changes